In order to factor, we really need to know how to multiply out our binomials. It's the easier part, and so we're going to use that to be able to see patterns. So in these 3 practice ones. Now, really, we probably could use 2 different methods for this. One is we use this acronym FOIL. And so for FOIL, it's just an acronym, so it means something. So the first one is really, so what we're really doing here is we're distributing through. So we're distributing the x to both of these. We're distributing the 3 to both of these. And so this FOIL is just an acronym, so the first ones. So first, meaning the x, the first terms in each ones. So the x times x, in this case, would give us an x squared. And then we look at the outside. So the outside here would be this x and this negative 5. So when we multiply them, we get a negative 5x. And then after that, we're looking at the inside, and so that's 3 and x. So they're on the inside of those, and that would be a positive 3x. And then the last ones, we're looking at that 3 and the negative 5, and that's how we get negative 15. Now typically with this, your middle terms will add together. Okay, now that's just because if we have an x term and a constant in both these binomials, that will happen. So they're like terms, so that becomes a negative 2x. So our answer then is x squared minus 2x minus 15 is the same thing as x plus 3 times x minus 5. Now another way we could do this that is the same mathematically, but the organization is a little bit different, is we could use a box to be able to do this. So if I start off with a box, okay, we're going to put our x plus 3 on the outside of one side, and so I'm just going to do it here. So I'm going to line up the x in one column and the 3 in the other column, and then the x minus 5 in the other one. So the x in the first row and the negative 5 in the next one. So then I'm just multiplying together. So this x and this x, it meets in this box, so this becomes an x squared in here. So then x and 3 meet in this box here, so we get a 3x when we multiply them. Down here, the x and negative 5 meet in this box, and then 3 times negative 5 gives me negative 15. Now, a lot of the times, these middle terms here, or these diagonal terms here, will add together. And so when I write this, I usually start with the highest power first, so I start with my x squared, and then those 2 x terms will add to be a negative 2x, and then I have my negative 15. Notice how I have the same thing in both of these cases. And I should, because I am just multiplying both of them. Mathematically, I'm doing the same thing. The organization's a little bit different. Okay, so if I look at the next one, I'm going to do the FOIL with this next one. So I'm going to distribute and get a 36x squared. I'm going to distribute this. I'll get a negative 30x. I'll distribute the 5, a positive 30x, and distribute the 5 there. These lines can really help you to organize you to just show you that first outside, inside, last. Oops, I forgot my squared here. So if I combine these middle terms, they add up to 0. So I'm left with just a 36x squared minus 25. Okay, that's kind of an interesting one where the middle one adds up to 0. That will be powerful when we're factoring. And then this last one, we see that we have the same factors there. So we're just going to write them twice because exponents are not distributive. Multiplication is. I'm going to do this one with a box just to show that one again. So on the outside, I'm going to put a 2x minus 3, and I'm going to do the same thing the other way since they're identical. So 2x times 2x gives me a 4x squared. 2x times negative 3 is a negative 6x. Again, 2x times negative 3 is a negative 6x. And negative 3 is positive 9. These terms will combine together. I'll start with my 4x squared minus a 12x plus 9. Those middle terms did not cancel out in this time. Okay. So this is just multiplying out. If we were factoring, we would start like with this end answer, and we would try to bring it back to what we had started with for this. So we'd be going the opposite direction. We can see a lot of patterns that happen here, and we can use them to be able to know how to factor.